Hello class. Today we're going to look at some new kind of code in Java. In programming, we often need to repeat certain actions multiple times. For example, printing a series of numbers, or checking if an input is valid, or processing items in a list. Writing the same code over and over is very inefficient, so Java provides us the ability to write loops to make repetition easier and more flexible. There are three kinds of loops that we're going to look at. The first is the while loop. So if you remember back to our if statement, the if statement had a condition, and if that condition was true, we executed a block of code. Well, we're going to look at a while loop first. The while loop also checks a condition and will only run the code inside the loop if that condition is true. It's very useful when you don't know how many times you need to run a loop and you don't know what the condition is. It is a very flexible loop. It is meaning that you can use it for just about any looping project you need. The next one we'll take a look at is called the do-while loop. Very similar to a while loop, but the main difference is that we don't check the condition until after the loop executes once. So the main difference between a while loop and a do-while loop is that a do-while loop will always execute one time, while a while loop may not execute at all. And we'll see examples of that code in a little bit. And lastly, the for loop, which is great if you know the exact number of repetitions of a loop that you want to run, like counting items on a list or counting items in an array. And Java provides us some very shorthand syntax to enable this, so we don't have to worry about all the little details that we're going to need to worry about when we write while loops and do while loops. So let's take a look at some examples now. So we'll start out with a very basic loop, a while loop. And I've already started up our lab tester over here. And what we're going to do is we are going to write a simple loop that counts from 0 to 5. So we'll need, of course, a variable. We're going to use an integer variable. And we'll start it at 0. Next, we'll write our while loop. While is your command. And then, as similar as we did with an if statement, we're going to create a condition. While counter is less than 5. Then we execute this code block. So, again, like an if statement, everything gets executed inside that code block between the curly braces if that condition is true. And we'll do a system.out.println current value is, and then we'll add in counter. Now, we need a little more. This isn't quite enough to make the loop run the way we expect it. This will print out the current value of what the counter is, and currently the counter has a value of 0 because we haven't done anything with it yet. And what will happen is, as we come in on line 11, we'll evaluate the value of counter. We'll see 0 is less than 5. We'll do this print statement, and then we'll come back after the loop is done. We come back and check our condition again. Well, counter still is 0. 0 is still less than 5. So we're going to print the statement again with the counter value of 0. Then our loop will end, and we'll come back up and check our loop condition, and we'll see the counter is still 0, and you see where this is going. Nothing is going to change. So unless we manually update the value of counter, this loop will run forever, or until the computer dies, or hopefully the programming language is smart enough to catch it and realize that we have what is called an infinite loop. An infinite loop is simply a loop that has no way of exiting. So with a while loop, we can build that into it. We can do a counter equals counter plus 1 to increment the value of counter, our variable that we're using to keep track. This way, we will eventually get to a point where counter will be equal to 5 and the loop will exit. Now, a more common way of writing this is counter plus plus, so we'll stick with that because that is the more widely used convention. So remember, the counter plus plus increases the value of counter after it's used. Well, in this case, it's only updating itself, so it's just going to update its value from 0 to 1. So if I run this loop now, we'll see it does, in fact, pending any typos, print the values of 0 through 4. The loop does execute the 5 times, as we thought. It goes from 0 to 5. Once counter becomes 5, which is here, on line 13, 5 is not less than 5, and the loop exits. Very basic loop, very basic while loop, allows us to do some great things. Anytime you need a repetitive task, a while loop could be your answer. So just to summarize again, on line 11, we have the command, the while command. We also have the loop expression, which is counter less than 5. And then we have the loop body. The loop body is everything inside the curly brackets. Once the loop body is done executing, when we reach this ending curly bracket, we jump back up to a line 11 and we reevaluate the condition. What would happen if we started counter at, let's say, 6? Well, when we start counter 6 on line 11, 6 is less than 5. No, it's not. So what will happen is, when I run this, you will see my program produced no output, which is correct because this is false. Once this becomes false, we do not execute the loop. The loop only executes when this value, the loop expression, is true. So let's reset it to 0. Now, let's take a look at the do while loop, which is very similar. And for purposes of this, I am going to comment out this code, and then we will write a do while loop. And you'll see the syntax is very similar. We start with the command do, because it's a do while loop. So here is our code block. We are going to do whatever is in this code block. And I am going to cheat a little bit. I'm going to copy the code from before and reuse that and line it up to make it look nice. Do not even while yet, do this print statement and increase the value of counter. And now we put in the while part. Counter less than 5. Now, something to note, and I'll point this out now, is after this while part, we do need a semicolon because it is not a curly brace. Curly braces, you do not put semicolons after. So in this particular case, we do need it. So if I run this code here, click run, the output looks pretty much the same, doesn't it? 0 to 5. 0 to 4, sorry. Output's exactly the same, did the same exact logic. The difference here is that we jumped into the loop and did something before we even checked the counter. Now, what would have happened if counter was 6, like we tried before? With the while loop, it printed nothing. What do you think is going to happen when we run the do while loop? Let's try it. Current value is 6, which is interesting. We said that we do not want to run this loop when the counter is greater than or equal to 5. We only want to run the loop when the counter is less than 5. Well, since we're doing our check of the loop expression after the loop already executed, we have no way of telling what that is. So we are going to run this piece of code, or this code block, regardless of what the counter is, or whatever the check value is. So it's always going to run once. A while loop may not run at all, depending on this condition. A while loop always runs once, regardless of what the condition is, because the condition is checked at the end. So let's reset the value to 0 and get ready. So one other thing, and maybe this another analogy here will help. I'm going to comment this out for a minute because we're going to jump into for loops in a little bit. But I want to jump over to an analogy. So picture yourself walking in the streets of Manhattan, New York City, and you come to a traffic light. Well, if we were using the while loop mentality, we would check the light to see if we can walk first. If the light is green, then we will take a walk across the street. If the light is red, we do not walk, we wait. So you can think of a while loop as that. You wait for the green before you can start walking. If we were doing the do while mentality, we would take a step off the curb into the street, and then we would look up at the light. Well, you could get lucky, and there could be no taxi coming by to flatten you, or you could make it across the street, or you could get hit. So a do while loop does not check. You take one step, and then you look at the light. If it's green, you can continue. If it's red, you stop after the first step. So you need to be extra careful with the do while loop. Okay, let's take a look a little bit more at a while loop, because that's the one we're going to be using the most until we get to arrays and lists and such, when we'll probably be using the for loop a bit more. But let's take a look at some examples with the while loop. So let's write some new code, and this time we're going to use the scanner. And we're going to use the scanner to read a character from input. And the idea is that we want to tell the user to press yes to continue, or something along those lines. Maybe we only want to do some math, or I don't know. We'll create something in a loop. But we're going to need a variable, first of all. We're going to call it, we'll make a character variable. We'll call it input character. Input character equals blank. And let's create a loop while input character is equal to y. And notice I'm using the double equals, not a single equal for assignment. And we can use our counter. Why don't we increase our counter? We'll increase the counter by 1. Actually, let's make it a little more interesting. And then we'll increase it by 2, or multiply it by 2. So we'll do a little math. Okay, so we'll add 1 to a value, then we'll multiply it by 2. And let me just clean this up a little bit here, make it look a little easier to read. And we'll see what the output is. So while the input character is equal to y, we will do this little bit of math, and we'll come back again. But first, we need to ask the user to enter a character to try again. So we'll put a print line statement in there. Press Y to try again. Anything else to exit. And now we'll need our scanner so we can do some input. So if you remember from the last chapter, we will use the scanner and that .caret syntax to get our next character. So we will do input character equals scanner dot next dot caret 0. And we'll make sure we have a scanner defined, which we don't. So let's put one of those in. New scanner system in. Oops. In. Semicolon. So we have our counter, we have an input character, we have a scanner, and that should do what we need. We have our math, we have our loop. While the input character is y, add 1, then multiply the whole thing by 2. I guess we probably should print out that value too, right? Let's do that. System.out.println new value of counter is, and we'll add in counter. There. So now we can see what the value is. Oops, resume. Let's get that going. And let's run our lab and see what we get. What does it not like? Empty literal character. Oh, okay, so we have to put something in there. So we'll put a space in there. That's fine. And we'll run the code again. And, oh, I missed a semicolon. I'm good at that. semicolon. There we go. Program produced no output. Why didn't it do anything? It should have come into our loop, and it should have done some math, and it should have gave us this option to continue, but it did nothing. Well, if you look how we have our loop defined, we are defining our loop based on the value of input character. So our input character currently on line 10 is blank, and we're checking it to see if it is Y. Only if it's Y will we run this loop. So use this as an example of when you want to control the input in a loop from a user or some other value, you need to give it an initial condition. And the initial setup for input character, in this case, is Y. This way we can get the loop started. Allow loop to run the first time. So this will allow us to run the loop the first time. Alternatively, we could have used a do while loop, and we'll rewrite this in a minute after we get it working. We'll rewrite this as a do while loop. So let's give it a try. New value of counter is 2. Well, it was 0. Line 31 changed to 1. 1 times 2 is 2. Do we want to try it again? Yeah, let's try it again. New value is 6. Okay, so it was 2. We added 1 to get 3. 3 times 2 is 6. Well, if we try it again, before we run it, let's think about what that value should be. 6 plus 1 is 7, and then 7 times 2 is 14. I would expect to see 14 here. Good. So sometimes it's good to think about it while you're testing to see what the output is to match what you're expecting what it is. And in this case, it does. So if we type anything else, the program ends. So we now have seen a couple of versions of the while loop, one where it counts, one where we're getting user input. Let's see if we can convert this loop to a do while loop to do the same thing. So we do, and we use all our code. I will copy this over so I save time from typing. And I'll clean it up and make it look nice. And we see we have the whole counter thing, and then we can take our while and we can put it here with the semicolon at the end of course. I'm going to comment out this, and I am going to comment out this. Now, since we are not checking the condition until the end, it does not matter what the initial value of input character is, since we're starting it as a space. So it will always do it this one time, at least to begin, and there's our 2. If I type Y, we get 6, Y again 14, and then we can quit. Now, while this does work without setting the initial value of input character, I highly recommend setting the value of input character before you start your loop, because you don't know necessarily what all this other code here is doing if this is a really big program, and you don't know what the value of input character is when you start. Maybe somewhere up here hidden, and unbeknownst to us, is input character equals Y, or X, or something else. So when we run it, it will blow up and not work. So always set your initial variables when you enter a loop. Make sure you have it set the way you want it to. This way you can be assured the loop is going to do the way you want it. So this is good. This shows you how you can get input and control input in a loop, whether it's from a while loop or a do while loop. Now, I had mentioned before about an infinite loop. So I'm just going to comment this out for now. So an infinite loop is exactly what it says, a loop that does not end. Now, historically, infinite loops have been bad. They will chew up your computer's resources and just keep running forever and ever and ever. And depending on what's in your loop, it could use up all your computer's memory, or it could cause a printer to print all its paper, or something along those lines. But infinite loops also have reasonable and useful applications. Think of a gaming application. You want your character to be able to move around indefinitely, depending on what the inputs are to the controller or the keyboard. An infinite loop might be very useful for that, so the game doesn't end until you're ready to make it end. In a situation like that, if you wanted to do a gaming application or something where you wanted an infinite loop, you could just do something simple like this. This loop does not end. So this simple little construct, while true, that loop condition will always be true because true is true. That loop will run forever. And now you can do your game or whatever other application you want it to do that never ends. But there is a way to get out of it. Let's say you, during this while true loop, and let's steal this code again, and we'll use it again for an example. So while true, we do our math, press Y to continue, and we'll get the character, and let's run it and see what happens. And we know what's going to happen if we press Y. We get 2, then we go to 6, and then we go to 14, and then we decide we want to quit. Up 30, it's not exiting, not stopping, won't end, etc. And it keeps going and going and going and going. Stop, won't stop. So what we have here is a problem where the loop condition is always true, and we're asking the user to enter input to stop the loop. So there's two ways we could stop the loop. The first way is a statement called break. And we can write a break statement like this. If, and we're going to use an if statement because we want to make the break statement conditional. If, what was it? Input car equals, no, only 2, equals Y, break. How'd that get all the way over there? We don't want that. There. Break. Break says exit the loop. End the loop. So we're going to run that. 2. Yes again. Exit right away. As soon as it exited, hit Y, it exited. Not exactly what we wanted. We wanted it to try again. So we want to reverse this logic. If character is not Y. So if it's not Y, we exit the loop. If it is Y, we try it again. Let's try that one more time. I want to try again. I want to try again. I want to quit. Perfect. So we essentially took the logic that comes up here in the loop condition and built it ourselves. So there's another way you could exit the loop. Let's say we want to do a little more math here. Let's do counter plus equals 1. We'll add another 1 to it. Actually, just do plus plus again. I'm going to take that. I'm going to leave that in, counter plus plus. If, and above it, we'll do a different kind of statement. If counter is less than 20, and we're just arbitrarily picking 20 for no other reason whatsoever than I wanted to use 20. If counter is less than 20, then we add 1 to it. Else, continue. No, that's a bad example. Let me redo that. That's not a good example. If counter is less than 20, continue the loop. Otherwise, counter, that's better. That's a better loop. Counter plus plus. And I can't spell continue. Let me fix that. C-O-N-tinue. System.out.println after the continue. So break does a end of the loop. It stops the loop for wherever it is and exits the loop so the code continue processing. Continue does something slightly different. It exits this current iteration of a loop. And when I say iteration of a loop is every pass through this loop from curly bracket to curly bracket is an iteration. The continue will exit the iteration of that loop and jump back up to the loop condition and reevaluate. So when we get to less than 20, it will continue. It will not do this print statement. It'll continue doing this math until we get back to over 20, which then we will then see after the continue. So let's run that and see how it goes. So the new value of counter is 2. So far, so good. We are not going to do Y to break. We want it to continue, so we're going to do X. Oops, I got that backwards. We did want it to continue. We did want Y. Let's rerun that. I want Y to try again. Counter is 6. 6 is less than 20, so it did not do the print statement because we hit the continue. If I run it again, we have 14, and I run it again, we have a 30. And now, finally, once we get past that that statement here on line 58, counter is less than 20. Counter is now no longer less than 20. We increase it by 1, and then we do the after the continue, and here it is. So break gives you a way to forcibly terminate a loop and exit it completely. Continue gives you the ability to exit a loop iteration and try again. Okay, so I'm going to save this code. I'm going to then start up a new lab window, and we're going to take a look at a for loop. Okay, so let's clear out this lab, reset lab to template, reset. Let's wait a few seconds. So while this is resetting, let's talk about what a for loop is. So a for loop is a specialized version of the while loop where we build into the syntax of the for loop the initial condition of the variable that we want to track, its ending value, and its step increment. It's a great loop for counting a very specific or known value number of things. So we're going to build back into it our loop counter. We'll start with counter. Actually, we don't need counter. We're going to start directly with the for loop, the for. And the for loop looks a little bit weird as compared to everything else. We are still going to have our, oops, let me get that out. I'm still going to build out our loop body. I'm just going to leave the double parentheses in here for now so we can build that in a second. But based from our other lab where we did the counter and the try again piece, I'm going to take that code and I'm going to put it back in for our counter. And I am going to, well, we're going to take away this Y to continue thing because we really don't need it. We can if we wanted to, but for this demonstration, we really don't need it. So what we're going to do with the for loop is define some values. So let's say we wanted to run this loop exactly 5 times. Well, we could do this, and this is the syntax. I'll write it out, and then we'll talk about it. Int I equals 0, and then we have a semicolon. I is less than 5, so remember we count from 0 to 5, so we're going to get 5 different executions. 0, 1, 2, 3, and 4. And then I plus plus. So what does this all mean? Well, let me create that counter variable first. What does this all mean? Well, we have 3 parts of the for loop. We have the loop variable, in this case I. I is going to be our loop variable. It's going to be used to keep track of our iterations in the loop. We have our loop expression. This is similar to the expression in the while loop that tells us keep executing this loop as long as this condition is true. So as long as I is less than 5, we execute the loop. And then here's our iteration, or our loop update variable, I++. So we're increasing it by 1. So if we run this loop, you'll notice I have counter 0, and I run this, pending any typos. There are our values, 2, 6, 14, 30, and 62. So we could see how our value increased. Every time we ran it exactly 5 times, and we did not ask the user for any input. We did not do anything with counter for checking the value. We just ran the loop. So we didn't ask for anything else. Everything was built in here. So again, with the for loop, we can start with a known value. We can set a maximum value, how far we want to go. Now, what's interesting about a while loop is that we can not only count by 1, we can count by 2. Let's say we wanted to increase it by 2 instead of 1. Well, now I goes from 0, 2, 4, 6. So you have different ways of doing your increment as well. A very shorthand version of a loop. Everything is defined right here on top of line 11 in the loop, in the syntax. So you don't need to worry about updating I as your variable in the loop. You don't have to worry about your exit condition. It's already defined. Everything's all set and ready to go. I use this loop a lot in programming, especially when I'm processing an array or a list. When a list has a fixed number of items in it, we know what the start is, what the end is, and how to get to the end of it. So we have a quick summary of the 3 loops. The while always executes once, and you have to manually update the loop expression. The do while loop, I'm sorry, let me take that back. The while loop does not execute always. It may execute no times if the loop condition is false. The do while loop executes always once, and that will depend on the condition that you're checking at the end of the do while loop. The for loop may or may not execute as well, depending on what your values are for your loop variable and your loop expression. If I had set this loop value to 6 for some reason, and I ran this, my program should produce no output, and there it is. So the for loop runs depending on the conditions of the initial variable and the update variable. And just wrapping it up with our traffic light example, the for loop, and there's some syntax there. Use the for loop when you know how many times you want to run the loop. Like you need to take 5 steps across the street, you would use the for loop. Okay, so back to our lab. Let's wrap this video up now. We're just at about 35 minutes. We'll come back next in another video and we will look at some string comparisons. We have to do a little bit extra with comparing strings, so that'll be something interesting. We'll talk about nesting loops, and then we're going to talk about variable scope, which comes into play. And we can kind of see it here a little bit where this int I equals 0. And we'll explain a little more what that is in the next video. Okay, so that's it. At least for now. Have a look, try your labs. If you get stuck, feel free to reach out. You know where I am, and I'll see you in the next one.